The submarine captain starts ascending at a constant angle of inclination of 20 degrees so that he can surface in 5,000 feet. So it looks like this is the submarine's right here, and he starts surfacing. He starts ascending at an angle of 20 degrees, so he starts going in that direction. So this is our angle of 20 degrees, and he wants to surface. So I guess this is the surface right over here of the water. He wants to surface after traveling 5,000 feet in the horizontal direction. Changes in pressure are very important in submarine travel, and the pressure in kilopascals is given by the equation. The pressure in kilopascals is approximately 2.990 times your depth in your depth, and I guess it's going to be feet, plus 101.3. What is the current pressure, P, on the submarine at depth D? Round your answer to the nearest kilopascal. All right, so if we can figure out, and they've kind of drawn a nice right triangle for us, where this angle right over here is 20 degrees. And so if we can use a little bit of mathematics to figure out what D is, then we can substitute D into this formula right over here and figure out the pressure in terms of kilopascals at this starting depth right over here. Well, how do you do that? Well, if you're dealing with a right triangle and you know an angle and you know one of the sides, you might remember that your trig, your definitions of your trig functions might come in handy. And for just basic right triangles, we always want to refer to SOH, TOA, where SO says that sine of an angle is equal to the ratio of the opposite side to the hypotenuse. Cosine of an angle is equal to the ratio of the adjacent to the hypotenuse, and tangent of an angle is equal to the ratio of the opposite side to the adjacent side. So we have our angle here. Now what sides are we trying to deal with? We're trying to deal with this side right over here is the opposite side. And if any of this looks foreign to you, I encourage you to review the basic trigonometry on Khan Academy. And then this side right over here, it's not the hypotenuse, it's the adjacent side. You could argue that the hypotenuse is also right next to it, so some people would call it adjacent, but we would call this the hypotenuse. That is the longest side of the right triangle. And then the adjacent side that is not the hypotenuse, that's the one that we call the adjacent side. So this is the adjacent side. So we're going to be dealing with the opposite and the adjacent. So which trig function comes into play here? Well, tangent deals with the opposite and the adjacent. So we know that the tangent of 20 degrees is going to be equal to the ratio of the opposite side or the length of the opposite side to the length of the adjacent side. So it's going to be d feet over 5,000 feet. Or if we want to solve for d, we can just multiply both sides of this by 5,000. Multiply both sides by 5,000, and we're going to get d is equal to, I'm just swapping sides here, is going to be equal to 5,000 times the tangent of 20 degrees. And then we could take whatever this value is and substitute it down here and round to the nearest kilopascal. Well, tangent of 20 degrees, we're going to need a calculator for that, and luckily we have one. Now, when you do this, when you use your calculator, you want to be very careful that you are in the correct mode. So you want to be very careful that you are in degree mode. Depending on your calculator, there's different ways of going between degree and radian mode, and I encourage you to get familiar with that. That's just going to be useful for you, potentially on the SAT, but for sure when you're in trigonometry class. But I'm in degree mode here. So I could take 20 degrees and take the tangent of it. So that's this right over here. And then multiply it times 5,000. So times 3 is going to be equal to this. So that's my depth, 1,819.8511. It keeps going feet. And now I can substitute into this formula. So let's see. If I take our d, this is our d, multiply it by 2.990. So let's multiply it by 2.99. Well, I could throw a 0 there, but it's not going to change the value, is equal to that. And then add 101.3. So plus 101.3 is equal to 5,542.65500. And let's see, I want to round to the nearest kilopascal. This P here is given in kilopascals. So it's going to be 5,540. I'm going to round up because I have a 0.6 here. 5,543. So P is approximately 5,543 kilopascals. Kilopascals, based on the information that they gave us. Put a comma there, not a decimal, a comma. There you go.